Hello and welcome to my first ever calculus video. This is also the first video in this series playlist, and this whole playlist is going to cover ways to, or tests basically to find the convergence or divergence of a series. In this video I'm going to be talking about the nth term test for divergence and the p-series test. So in our first example, just to introduce the nth term test, for divergence, we have this series, the sum as n goes from 0 to infinity of -1 to the nth power. So what the nth term test for divergence basically says is that you can take the limit as n approaches infinity of whatever the series is, so that would be -1 to the n, and if that limit does not equal 0, then the series diverges. If the limit equals 0, then the test is inconclusive. So, I'm sorry, I actually didn't need those equal signs there, but I just wanted to illustrate this point. So when we take the limit as n approaches infinity of this a sub n part right there, -1 to the n, and if we plug in infinity for n, is the limit going to be 0? Well, the answer is no. What's that limit going to be? Well, it's going to be it's going to be -1 to the power of infinity. I don't know what that number is, since that's constantly oscillating, and I don't know if infinity is even or odd, but I know that it's certainly not equal to 0. Therefore, I can say by the nth term test for divergence that this series right here is definitely going to diverge, since that limit does not equal to 0. I'm going to do another example of this, but I just want to really emphasize the fact that all this test does is take the limit as n goes to infinity of this part of your series, and it's just determining whether or not it diverges. You can't say that it converges by this test, which is really important to recognize. If the limit equals 0, that doesn't necessarily mean that it doesn't diverge. It could still diverge, and I'll show you an example later where that happens. Okay, so in our second example, I have a little more complicated. The sum as n goes from 1 to infinity of 2 to the power of n plus 1 divided by 2 to the power of n plus 1. So the first thing, obviously we're going to use the nth term test for divergence, and later you'll probably understand why I'm going straight to the nth term test for divergence. And the first thing we're going to do is take the limit of this part. So limit as n goes to infinity, as n approaches infinity of 2 to the n plus 1 divided by 2 to the power of n plus 1. And the first thing that we always do when we have any kind of limit problem is reduce, which is what I was saying. And so we're going to reduce this, or just not necessarily reduce, but simplify. So 2 to the power of n plus 1 can also be written as 2 to the n times 2, which is why pre-cal skills are so important in calculus. And now we're going to rely on one of our basic limit techniques, which is taking the highest power in the denominator and dividing every term by that highest power, or basically the heaviest, most important term. And in that case, it's definitely not the 2, and it would be the 2 to the power of n. And so I'm going to divide everything by 2 to the power of n. And now I'm going to rewrite my simplified limit expression. So 2 to the power of n over 2 to the power of n is simply 1 plus 1 divided by 2 to the power of n over 2. Now, I can say what happens when I actually plug in infinity for n. And what happens, So I don't know what 2 to the power of infinity is, but I do know that it's a very, very large number. And 1 over some number that's approaching infinity is always 0. And so that leaves me with 1/2, since I have 1 plus 0 over 2, which reduces to 1/2. Now, because that limit is 1/2, remember that by using this test, you are proving that the series diverges, but it doesn't, or you can't tell. So by this test, we would say that the series diverges because the limit as n approaches infinity is not equal to 0. Okay, next example. So in this next example, we have the sum as n goes from 1 to infinity of 1 over n. So we are going to apply the nth term test for divergence. And when we get 1 over infinity, we end up with 0. And the nth term test for divergence is inconclusive. This is the point at which we realize that we need to learn another test. And that test is the p-series test. And the p-series test applies to any type of series. I'm not going to fill in the top and bottom because it could be anything, where you have 1 over n to the power of p, and that p can be seriously anything, well, as long as it stays in the denominator, so it's positive. P is greater than 0. And then we have these rules. If p is less than or equal to 1, by the p-series test, that series diverges. And if p is greater than 1, that series converges. So we can say that by the p-series test, p in this case is equal to 1, and the series therefore diverges. And that's the p-series test. So we're going to do another example to better illustrate the p-series test. This is our last example. And this example does not look like the others, and that is because it's not written in series format. So if I can get this whole thing in the frame, you can actually see that this is a sum that extends to infinity, which is by definition what a series is. So I'm going to have to say that this up here is going to be equal, or the same thing as the series. I know that it's going to infinity, and it's starting at 1. I'm going to change that. And for that, basically what we have is n times the square root of n, so that 1 over n times the square root of n. And you can see that right now because when n is equal to 2, you get 1 divided by 2 square roots of 2, and it just keeps going on and on. So that's what we have there. And you might be thinking, I can't use the p-series test with this. And my response to that is, yes you can, because we can simplify. And when we simplify, we have n times n to the power of 1/2. And again, I said that those skills with exponents are so important. And so you need to be able to recognize that you can add those. So you have n to the power of 1 times n to the power of 1/2. And so that's the same thing as n to the power of 1 plus 1/2, which is the same thing as 1 over n to the 3/2. So now I can say that my p equals 3/2. And 3/2 is greater than 1. And so therefore the series converges. So I really hope that you learned something from this video. Please comment if you have questions, and I hope to see you in my next video.